including occupational safety and health, industrial hygiene. We're the second oldest environmental engineering accredited program in the United States. Over 40 years in that business, ecology and restoration. Our business program has a land management minor with that. And our bureau, the Montana Bureau of Mines and Geology, I call it the keeper of Montana water information. And then we have a number of other programs, nursing and health. And I mention health in particular because I think that the nexus between energy and health is not indirect, it is very direct. And we've seen some of those conversations earlier today regarding energy versus how healthy our world is. And then that relates to national security as well. Our Highlands College, our 2-year programs have welding, machining, diesel mechanics, auto mechanics. They also have a lineman program that's strongly supported by Northwestern Energy. So our impact is really great. We pull our alumni from time to time, and we have found that we have graduates that are working in 49 countries. And so our institution is actually pretty international, and the impact that we made around the world is unbelievable. And out of our 3,000 students, we have students from 22 different countries, and about 6 or 7% of our students are actually international students, and about 78% are from Montana. We talk about an ordinary to extraordinary kind of experience at Montana Tech, and Ryan Lance is just one example of, coming from, Great Falls, I guess not small town, but Wolf Point certainly, right? Ordinary to extraordinary kinds of lives. Gary Kolstad, Jerry Schuyler, Mr. Holsworth, Terry Holsworth, right here in Billings, right? Tom Hone, just to name a few. Brad Archibald and Josh Vincent have started significant environmental firms here in the state. So just a real impact on the state of Montana as well. In terms of research, we do about $11 million a year, $3 million in engineering, mostly in power engineering, $6 million in geoscience and natural resources, and about $2 million in environmental ecology and restoration kinds of things. Our partners include DNRC and DEQ from the state, industry, and we have strong industry partnerships with many of the companies that have been represented here. So just sort of in summary, let me just give you maybe 2 or 3 real strong points. And the first one is that our football team beat Carroll twice last year. Yeah, so I know that's very much related. Frontier Conference champions, 10-2. But on the educational side, we have strong programs around the state. Montana State and Montana Tech have really connected to the energy business. I graduated in 1985 from the University of Wyoming with $8 a barrel oil, and at that time, Wyoming closed down their petroleum engineering program. And I always tell people, it wasn't Rhode Island, it was Wyoming. Right, and so at that time we were told that we were running out of oil, but this is a really different downturn, and there are tremendous opportunities on that side of things for our graduates in the future. There's also the silver tsunami coming on, and Ryan could speak more about that, about an aging workforce. And so I would tell our students, our prospective students and parents, that there is tremendous opportunity in the future for it. In terms of research, just a couple of points. We should not lose our ability and our knowledge in extractive metallurgy and mining, nor should we lose our knowledge in the area of natural resource, and in particular, clean coal technologies. We should be leading the world on that, because the problem is not in the United States, the problem is going to be in the developing countries around the world. And with that, John, I think I'll stop and pass it on to George.
Okay, thanks, Donald. Did want to say that speaking of impact, many of you know our news anchor, Jay Cohn. Well, he is out of pocket for the next several days because he is visiting one of your graduates. His son, Andy, is a petroleum engineer graduate from Montana Tech, and Jay mentioned to me that he's doing so well. Andy, bought Jay's plane ticket down to Houston. So I did want to mention that. Let's welcome George Booras. He's the principal technical leader at the Electric Power Research Institute in Palo Alto. He's been with EPRI since 1989. He manages the advanced power generation technologies there, and he is a graduate in chemical engineering from UC Berkeley. George, welcome.
Thank you, John. It's a pleasure to be here. I wanted to give you a little bit of background about the Electric Power Research Institute in case you might not be familiar with the organization. We were founded in 1972 as an independent, nonprofit, public interest research and environmental research company. It's a collaborative research model that we have. We're funded by more than 1,000 energy organizations. We have participants from more than 40 countries. Our EPRI members generate more than 90% of the electricity in the United States. Our international funding amounts to about 20% of our total R&D funding. We have major offices in Palo Alto, which is the office I'm from, and also Charlotte, North Carolina, and Knoxville, Tennessee. I'm a part of the fossil generation power sector at EPRI, and within that sector, our mission is to develop and provide the fossil generating fleet with safe, reliable, economic, and environmentally responsible technologies. I work in the area of advanced fossil technologies, which includes clean coal technologies, carbon capture and storage, but also a major focus of our research area in generation is maintenance and improvement of the existing fossil fleet, environmental controls, materials and chemistry issues, operations and maintenance, plant water management, and also we have a group that monitors progress in the renewables area. Within the advanced generation group, we are developing really the fossil power plants of the future. We do that through a three-pronged approach. One of them is monitoring technology progress. We look at advanced coal-based generation concepts. We look at new natural gas-based power generation concepts. So it includes not only coal, but also natural gas and the advanced fossil area. And we look at CO2 capture technologies. We work with others to accelerate the development of new technology. We're a co-sponsor of the National Carbon Capture Center in Wilsonville, Alabama. We are a member of the U.S. Department of Energy Collaborative for Advanced Fossil Power Materials. So we look at concepts that facilitate the more flexible operation that's required by today's power plants. Under the CO2 area, we look at new processes for capture and ways to reduce the risks associated with carbon capture and storage. So in summary, we're identifying new ways to generate power from fossil fuels while cost-effectively reducing our CO2 emissions. We really utilize two approaches within our area. One is evolutionary improvements. These would be things like higher temperatures and pressures in power generation cycles, improved post-combustion capture technologies. We look at improvements in the Brayton cycles, which would be gas turbines, higher firing temperature gas turbines, longer term, how those might integrate with coal gasification facilities. And we also look at revolutionary concepts, different ways of generating power that are more efficient, that are going to generate less CO2 per megawatt hour produced. And these would include areas like pressurized oxy-combustion, closed Brayton cycles using supercritical CO2 as a working fluid instead of steam, fuel cells, and other novel cycles. Just to give you a little indication of what might be achievable in the supercritical CO2 Brayton cycle area, we're looking at some studies where the natural gas-fired CO2 Brayton cycle could be capable of efficiencies greater than 50% while capturing 100% of the CO2. Now, when you turn around, you combine that with the coal gasification process, our efficiency is approaching 40%. And that, again, is with 100% CO2 capture. Longer term, working with solid oxide fuel cells and gasification, we feel that that technology might be capable of meeting the EPA New Source Performance Standard of 1,400 pounds of CO2 per megawatt hour without adding carbon capture and storage. In our CO2 capture area, we look at advanced solvents that are coming out. We rate technologies as they're being developed by what we call a technology readiness level. So the early stages would be pilot and bench scale work, working its way up to demonstration and commercialization. Most of the work that we do in that area is in the relatively low TRL areas, although we have been involved in some larger scale demonstration plants, such as the CO2 capture plant at Plant Berry in the US was a 25 megawatt using the MHI capture process. So that's just kind of an overview of some of the areas that EPRI gets involved in. I think one of the key things to note, and I'm sure it'll come out in subsequent discussions of this panel, is that research and development takes a long time. The turnover of power plants is not on a short-term basis, it's decades. And development of these technologies to move them from the low TRL levels to the higher TRL levels can take quite a long time, as well as quite a bit of funding to get them moved from one step to the next. So it's important that we continue that funding so that when we need these advanced technologies, they'll be ready for deployment, not only in the US, but throughout the world.
Okay, thank you very much, George. I do want to mention before we hear from Lee that we want to give you the opportunity to ask these experts questions before we get too much further down the line. So if you have questions ready, here's an opportunity here shortly. Lee Spangler is the director of Energy Research Institute at Montana State University in Bozeman. You may have already listened to Lee a couple of times here around this conference, an expert in carbon sequestration. And let's hear what's happening in Bozeman at Montana State. Lee.
Thank you. If you've been to some of the breakout sessions, you may have already heard a little bit about the research activities at Montana State. And I'll just give a brief overview. We work in really diverse areas, including wind energy, focusing on composite materials for turbine blades to make them lighter and more durable. We work in solid oxide fuel cells, which were just mentioned, specifically reversible fuel cells, so that if you have excess energy, let's say from wind, you can run the fuel cell in electrolyzer mode, split water into hydrogen and oxygen, then later use that hydrogen to produce energy from that same fuel cell. So you have one device that performs both tasks. We also have a lot of work in microbial processes and energy. So everything from looking at microalgae as a fuel feedstock. Algae produces more oil per acre per year than any oilseed crop does, so it's a bioenergy source. It also has potential to be used for other value-added products such as omega-3 fatty acids and for feedstock for both animals and also for fertilizer. We are looking at using an algal extract to enhance coal bed methane. A lot of the methane produced from coal is biogenic in nature. It comes from microbes that are already in the coal seam, breaking down the coal and producing methane. We've discovered that you can use an extract from algae to stimulate that process. So the idea is you would grow the algae in the coal bed methane pond, take the extract, re-inject it into the coal bed methane wells, let it sit, and then reproduce those same wells instead of drilling additional wells. Then another area where we're using microbes is to seal small aperture leaks. One of the challenges in the oil and gas industry is well integrity, and you can get delamination, debonding of the cement from the well casing, and this leads to very small aperture possible leakage pathways. If you have a large aperture leak, you can pump cement in, but a small aperture leak, the cement's too thick and viscous to enter. And so we're developing an innovative technology to inject bacteria, get them out of their dormant state by providing some nutrient, injecting a calcium source, and those bacteria then have a urolytic mechanism, enzyme that catalyzes formation of new mineral, calcium carbonate crystals, in those small aperture leaks. We've actually been funded to do a field test. It was successful, and we're getting interest from some of the major industry players, Shell, Conoco, to do another test for sealing shales in Switzerland. And we've gotten interest from a major oil field services company. That technology is being commercialized through a Butte, Montana company called Montana Emergent Technologies. Another major area we operate in is in carbon capture, utilization, and storage, also sometimes called carbon sequestration. We've done site characterization of a site in Montana. We do regional assessments. So this is an area that is the cornerstone of future clean coal, and we're one of the nation's leaders in that area. All told, Montana State University does about $100 million in research activities annually, about $15 million of research per year in the area of energy involving 300 people and roughly 190 students annually. And we view research and education as going hand in hand. These research opportunities help students develop critical thinking skills, they learn to work in multidisciplinary teams, and they learn real problem-solving skills. So I think it's a valuable part of their education to be involved in these innovative research activities.
Thanks, Lee. And again, we'll open it up for questions now from anybody who has a question that they'd like to ask of our panelists. I'll just jump in with the first one, and that's when you're talking about areas of $100 million in research funding. Where is the bulk of the funding coming from? Where is the platform? Is it federal, state, private dollars that go into funding these kind of research projects?
Well, the bulk of our funding is from the U.S. government. In the area of energy, it's predominantly from the Department of Energy, but not solely. There are other agencies that fund in that area. A lot of the more applied areas, like carbon capture and storage, require 20% cost share, and we are often able to get that from private industry. So there is a private industry component as well, but most of it is the federal government in competitive programs where we have to write a proposal that competes against proposals from other institutions. And then I do want to mention that the state recently launched the Montana Research and Economic Development Initiative, where they provided $15 million total to the university system on a competitive process. And we won one of those awards, and it's collaborative with Montana Tech, so we now have a state component to our funding as well.
And George, you're in a little different situation, as you do have members who also participate, but talk to us about your funding.
Well, yes, John, most of our funding does come from our member utilities in the U.S. and throughout the world. However, we do participate in some longer range research programs, and we do co-fund research in certain areas. We do have a number of projects under the DOE's ARPA-E program, which looks at much longer term technologies, breakthrough technologies. We have also applied and successfully participated in a number of the DOE's demonstration programs. I mentioned the plant-berry CO2 capture area there, where we provide through our membership funding the co-funding that's required to match the DOE contribution. So we have a variety of sources, but the primary research programs are member funded.
Okay, Donald, how about you?
We're very similar. I think Lee summarized that well. We do have a strong industry component as well, probably a little higher on a percentage basis than some institutions, as well as a lot of collaboration with the state.
All right. First question.
Sure, Paul Rogie from Creative Erg. It's encouraging to see the three of you on the panel talking about sort of three levels of value added, from producing energy or extracting it to improving materials to developing high-tech components. And so with all of this research going on and potentially being funded by federal agencies and others, what could we do to increase sort of the private industry development that would embrace these technologies and increase the value-added industry in the state, so that instead of sort of digging up minerals and energy and shipping them out, we actually employ people in increasing the value added and just ship smaller materials and equipment out that don't require so much transportation infrastructure, and by the way, don't depend upon other states to allow us to ship coal or these other resources through them. So we'd be maybe more independent in terms of our economic growth.
Well, I might comment on that. One of the things that EPRI has that is a good exemplar is that consortium of private industry that pays membership. So when you think about something like clean coal, extractive metallurgy, or whatever that area is, let's pick on clean coal, you know, having an industry sort of collaboration that puts money together that allows you to go get federal funding is a great model. And we haven't done that yet, and Lee might have some ideas on that as well. But, you know, around the oil and gas or the environment, those are great collaborations. EPRI has a nice formal model for that we could grow from.
Just a couple of comments on that. The deployment of a lot of these advanced technologies, as has been mentioned earlier in this conference, is really happening in the areas that are expanding their generation of electric power in China, Japan. China and Japan have some of the most advanced coal-fired power plants in the world right now because they're the most recently built. They're using steam conditions, which we would refer to as ultra-supercritical, very high efficiencies. In the U.S., there's less of a market for new coal-fired power plants, if a market at all right now. But where our emphasis is in the U.S. is what do we do with our existing fossil fleet? How can we utilize those assets that are on the ground, that have access to transmission, access to coal yards, and so forth? One of the examples that we're looking at is, can we apply our research in the Advanced Materials Program? And this is looking at allowing steam temperatures up to 1400 degrees Fahrenheit. This would greatly improve the efficiency of the cycle. You could go into some of the older existing plants and basically rebuild a portion of the boiler and add a topping steam turbine that would use that higher pressure steam, higher temperature steam. This would improve the efficiency of generation at that station. And if that plant was down the road required to add CO2 capture, it would make that a much less costly proposition because the plant is more efficient in generating less CO2. So we're looking at opportunities to partner with utilities and power plants to do initially feasibility studies of these retrofit concepts and eventually move into demonstration of those concepts. A great application here in Montana would be the coal strip plant that has been mentioned throughout this conference. That would be a great place to try to apply some of these advanced materials and hopefully keep that plant open and generating electricity at the highest efficiency possible.
Lee, do you have something to add there?
Just something briefly. One of the things we do is we try to license our technologies to Montana companies. And very often the next step in that is to participate in a small business innovative research grant where we provide technical input to the company taking it the next step with the help of government funding. That's how we try to transition our technologies into the private sector. When you're talking about exporting value-added products from energy, very often what we're working on is something that assists the energy industry, and then it might be a product that's utilized out of Montana, but it doesn't get to the point of taking energy-intensive state and instead of exporting the energy directly, developing products based on the amount of energy available in the state. That's sort of a next step, and I think it's a wonderful idea because you're exporting a higher value product, but that's sort of beyond where we operate.
Next question.
Hello, my name is Brett Gunning. I'm the Dean of the College of Engineering at Montana State University in Bozeman. And those of you that know me in this room, you know I'm not a very competitive person, but I did have to break into the Gold Digger Love Fest a little bit today. Or Digger. Or Digger Love Fest. So I'm going to change it. It's going to be blue and gold, and we're going to become gold diggers together. How's that? And I know Senator Daines, since he represents all the people in the state of Montana, he has to be a little bit careful about bragging about his alma mater, but I don't. Joking aside, what I wanted to ask the panel about was and I've talked with Don about this, so I think I know how he's going to respond, increasingly in higher education, to prepare the next generation of Montana-educated engineers requires a new partner in that enterprise. And I believe both Montana Tech and Montana State, by evidence of the people in this room, Senator Daines, Chairman Lance, we have done that historically. Don pointed out that they were recipients of a Goldwater Scholar this morning, and I've just learned the same news. There were a couple Goldwater Scholars from Montana State University. That's the next generation. So we're continuing to do that. The additional new partner we need in that enterprise is private industry. Historically, public higher education has been supported by tuition and the state. But increasingly, both he and I have been successful and have gained a lot of support from many of the organizations and people in this room in bringing that private partner into public higher education. So my question to the panel then is, do you agree about that importance of that partnership?
Mr. Ortiger, I'll let you start.
Thanks, and congratulations as well to Montana State University. I think that's exactly where research is headed. There's a lot of push for federal funding to result in something that's a little more short-term. And I'm a strong believer in sort of the fundamental research, the basic research that universities are known for. But I do think that is something that we can be better at, and the technology transfer that Lee alluded to, those are things that we have areas for improvement in. And one of the ways that we do that is to partner with industry. And to do that, which we do to a large extent, but if we can improve that, it allows us to work on problems that are relevant and a little bit shorter term in some respects, or at least sometimes. And then when you do that, then that allows us to take those things to market. I think the partnerships within the universities is improving. And we have a Ph.D. program that is in collaboration with the University of Montana and Montana State in material science. These are things that have to happen with a state that's our size. We have to come together with 1 million people, with the institutions around the state, as well as the industries that are depending upon us for that research, and solve these problems together. So thanks, Brett.
George, do you see private industry playing a bigger role?
Well, we at EPRI, we do work with a number of universities throughout the U.S. And as I mentioned, some of our more fundamental research, some of these lower technology readiness level, we depend on research that's being done by graduate students at universities to better understand the fundamental chemistry of the process that's involved, to help us define the physical properties, and therefore we can develop a process to utilize those new materials. So we do work with the universities to do that. We do hire summer interns that come and work at EPRI, either in Palo Alto or Charlotte, where they have an opportunity to get more of an industry perspective on the research they're doing at that university. And I think that's a very important program, because our future is in the hands of the up-and-coming engineers.
And I would echo most of what Don said, but I did want to emphasize one point a little bit further, and he said relevance. And the relevance is important both in the research realm, so we understand the applications for the basic work we're doing, and we can let it guide us. But it's also very important in the classroom, so that we understand the skills industry needs that maybe we're not currently teaching, or that we need to improve emphasis on. So I think relevance, that interaction with industry, is extremely important to prepare our students for the workforce.
Okay, we have another question back there.
You guys have hit on parts of my question, but I wanted to focus in on just the reduced economy that we have right now, the downturn. I really feel like in those times, it's a great opportunity to catch up on innovation and technology, but you're dealing with reduced funds. And so I guess I would like you to address that. And a second part to that question is, how do you reduce the time between research and getting something workable on the ground given reduced funds?
Well, you obviously can't do something with nothing. So if the funds reduce beyond a certain point, it really is a barrier. But what we've found is that we've actually become more competitive. So even though the research funds are reducing, our share of them is increasing. And I would say that's probably the best way to handle it is be more competitive. The way we're trying to reduce the time from research to implementation is we're getting more involved in field pilots so that we get it closer to that step, and that gets higher interest from industry at that point too, and their involvement can then shorten that time because we understand what issues they're concerned about, and we're not working on improving the wrong aspects.
You know, one of the things, those are good points, and I think Lee summarized that well. One of the things that we've noticed, you know, always trying to look for the silver lining is with the downturn, we've had pretty significant increases in our graduate programs from students who are coming back to school or continuing on to school, so sort of continuing to sharpen that saw a little bit. And so I think what you're going to see, you know, what you saw that came out of what I remember in the 80s as a downturn is the leaders in the industry are often those people who are in that downturn. And I think you're going to see the same thing in 10, 15, 20 years. So a little bit of a silver lining on that in terms of students coming back, getting more knowledge and skill in the area of how to do their job. And I think Lee's exactly right, making sure that our programs are relevant at both the undergraduate and graduate level is going to be critical.
George, we just have a minute left. Do you want to add something to that?
Yeah, I was just going to briefly add, that's a very important issue, and we too have seen some downturn in funding. But at the higher levels of our member organizations, they recognize the strategic importance of clean coal technologies, that these are technologies they're going to need in the long run, and they won't be available unless we're doing the R&D on these right now. So they recognize the importance, and even though it is a downturn in the economy, they must put funding into these longer-term R&Ds for the long-term success of the industry.
All right, gentlemen, thank you very much for your presentations today, and thank you very much out there for joining us on this panel on potential impacts of research and education. Obviously, we scratched the surface today. And again, thank you very much to Lee, George, Donald. Thank you very much, and enjoy the rest of the conference, everyone.